Welcome, everyone, to our deep dive into the Tunguska event. I'm sure you've heard the basics before, but just to recap, 1908, Siberia, this massive explosion, totally flattened trees, like over a huge area, like 2,000 square kilometers. That's twice the size of Rhode Island, if you can imagine that. But here's the thing. There's no crater, no impact crater. So, what in the world happened? That's what we're going to try to figure out today.
Yeah, it's really a puzzle, you know. Scientists, the public, everyone's been kind of captivated by this thing for over a century. And the Tunguska event, I mean, this was powerful. Estimated to be about, 1,000 times stronger than the bomb they dropped on Hiroshima. And yet it happened in one of the most remote places on Earth, the Tunguska River region of Siberia.
Right, like the closest settlement, I think it was a small trading post. It was over 60 kilometers away. And think about this, the first, real scientific expedition didn't even happen until 1921, 13 years later. I mean, Russia was going through a lot back then, so talk about a delayed investigation, huh?
Totally, absolutely. And when the scientists finally got there, I mean, what they saw was just incredible destruction, but without the evidence you'd expect, right? The lack of an impact crater, that just immediately threw everything off. I mean, how do you even have an explosion that big without a crater?
It's like a cosmic whodunit. So where do we even begin with something like that?
Well, there have been plenty of theories, let me tell you. Some more plausible than others. Early on, some folks even thought it was a mini black hole just passing through the Earth.
The black hole. I mean, I guess it explains the no debris part, but that seems, I don't know, kind of out there, doesn't it?
Yeah, the black hole theory, that was dismissed pretty quickly. There wasn't any evidence of those gravitational effects, the kind you'd expect from a black hole. But it does show how perplexing this whole thing was, and still is.
Okay, so then what are some of the more, I guess, down-to-earth theories? I know there's been talk about antimatter and comets, even meteorites, right?
Yeah. Let's start with antimatter, just because it's so interesting. The idea there is that a chunk of antimatter, that's that super rare counterpart to matter, collided with Earth, and that caused just a massive annihilation event.
Okay, wait, hold on. Back up for a sec. What exactly is antimatter? It sounds like something out of Star Trek.
Oh, it's real, but incredibly rare. Think of it like this. For every particle of matter, there's this hypothetical antiparticle with the opposite charge, and when matter and antimatter meet, they annihilate each other, releasing a ton of energy.
So like a cosmic explosion, but wouldn't there be some kind of radiation left over if it was antimatter? I mean,
Exactly, you're totally right. That's one of the big reasons the antimatter theory doesn't really work. There's just no evidence of more radiation at the Tunguska site. Plus, scientists haven't found any naturally occurring antimatter. At least not in the amounts you'd need to cause something like Tunguska.
Okay, all right. So we can cross antimatter off the list. So then what about the comet theory?
Oh, that one was popular for a while. It gave a potential explanation for that missing crater. A comet, mostly ice and dust, could have vaporized as it came into the atmosphere, leaving almost nothing behind.
That seems plausible. But wouldn't a comet that big, wouldn't it leave some kind of dust trail? Or at least some, I don't know, some change in the atmosphere.
You got a good point there. The thing is, to make an explosion the size of Tunguska, you'd need a pretty big comet. And even if it totally vaporized, it's likely there would have been atmospheric disturbances, maybe even stuff people could see all over the world. And there's just no record of that.
So the comet theory, that's starting to look shaky too. So does that just leave us with the meteorite explanation?
Well, it's the most widely accepted theory right now, but it still has its own problems, The main question is, how could a meteorite, even a big one, how could it make an explosion with the force of 1,000 atomic bombs? And if it was a meteorite, where are the pieces?
Yeah, that's what I was going to ask. You'd think there'd be at least something left over after an explosion that big.
Yeah, you would. But despite, all the expeditions, all the searching, draining lakes, sifting through the soil, all that, they've never found any definitive meteorite pieces. That's a pretty big hole in the meteorite theory.
So where does that leave us? No crater, no meteorite pieces, and a whole lot of questions. It's like Like this event was made to be a mystery.
Yeah, exactly. A true enigma. But before we get too stuck, there's one more thing we got to consider, and that's the eyewitness accounts. Remember, this didn't happen in an empty space. There were people, nomadic tribes living in the region, and what they say is really fascinating, gives us some real insights into what happened.
Okay, yeah, let's hear it. What did these eyewitnesses say about Tunguska?
Well, put yourself in their shoes for a minute.
Mm-hmm.
Living in this vast Siberian wilderness, totally in tune with nature, and then bam, the sky just erupts in this blinding light, brighter than the sun. That's what a lot of the Evenki people, a nomadic tribe there, that's what they said they experienced.
Oh, wow. I bet that must have been terrifying. I mean, we're talking about something that people felt hundreds of kilometers away.
Absolutely, absolutely. The Evenki they described like total chaos, this deafening roar, this wave of heat just scorching the land, trees getting ripped up, thrown through the air like nothing. Some even said they felt the ground shake like the whole world was splitting apart.
Wow. Yeah, that paints a powerful picture. It really gives you a sense of the sheer scale of this thing. But did they actually see anything? Like an object falling from the sky?
Some of them, yeah. Some accounts mention this fiery object, streaking across the sky, leaving this trail of smoke and sparks. Others talk about this pillar of fire rising up from the horizon like a giant tree had just burst into flames. But these descriptions, they're often, they're fragmented, not always consistent. It's hard to get a clear picture of what they actually saw.
So even the eyewitness accounts, they just add to the mystery
Yeah.
instead of solving it.
In a way, yeah, that's true. But their stories, passed down through generations. They give this human side to this whole scientific puzzle. They remind us that Tunguska, it wasn't just some abstract cosmic event. This was a real thing that really affected the people who saw it.
It is incredible to think about, like, the cultural memory embedded in those stories.
Yeah.
But do they give us any clues? Anything that could help us narrow down the possible causes?
Well, that's where things get really interesting. Because, hidden in these stories, there might be a clue that explains how Tunguska could release so much energy. A clue that leads us not to space, but to something much closer to home. The Earth itself.
Whoa, hold on. What are you saying? Are you saying the Earth itself played a role in the Tunguska event?
That's exactly what I'm suggesting. And the key to this theory is something you might not expect. Natural gas. Siberia, you see, it has massive reserves of natural gas, all trapped underground.
Natural gas. Okay, I think I see where you're going with this.
Yeah.
But how does natural gas explain an explosion that big?
Okay, picture this. A meteorite, doesn't matter what it's made of, it slams into the Earth's crust with incredible force. This impact, it creates fissures, cracks in the surface. And what if those cracks just happen to hit a pocket of natural gas?
So the meteorite is like a trigger, releasing this huge amount of natural gas up into the atmosphere.
Exactly. And here's where it gets really cool. Natural gas, methane specifically, it's highly flammable, right? And when you mix it with air in the right amounts, it can make a truly powerful explosion.
Hold on. Could a natural gas explosion really be that strong? Like rivaling 1,000 atomic bombs? That seems, I don't know, almost impossible.
It's a bold claim for sure. But some scientists think that combination, the meteorite impact plus all that natural gas suddenly released, they think it could, in theory, create an explosion that big. It's all about the synergistic effect, one powerful event triggering and amplifying another one.
Okay, so we've got this hypothetical scenario. Meteorite hits, releases the gas, boom, huge explosion. But wouldn't there be evidence of the gas? Wouldn't people have smelled it? Wouldn't there be, like, I don't know, a gas cloud or something?
Yeah. Those are all great questions. And the answer, or at least part of it, might be in the limitations of science back then. I mean, this was 1908, right? Our ability to detect and analyze gases in the atmosphere, it was nowhere near what we can do today. It's possible the gas, even though it was a lot. It just dispersed really quickly. It didn't leave much of a trace.
And what about the Evenki people? Wouldn't they have noticed the smell of natural gas?
Maybe, maybe not. Keep in mind, natural gas, when it's pure, it doesn't actually have a smell. That gas smell, we all know, that's an additive put in by, the utility companies for safety. So unless the gas had other stuff in it, stuff that made it smell, the Evenki might not have smelled anything out of the ordinary.
Okay, yeah, that makes sense. So it's possible this huge gas release happened.
Right.
And there wasn't any obvious evidence. But is there any actual scientific evidence to back up this natural gas theory?
It's a pretty new idea, but there are some interesting hints, For example, some researchers have found higher methane levels in tree rings from around 1908. And others have looked at the geology of the Tunguska region, looking for, like, signs of underground gas pockets and ways those gases could have reached the surface.
So we're talking about like a kind of geological detective work, huh?
Yeah.
Piecing together these clues, seeing if they make a story.
Exactly. It's a fascinating puzzle. You've got geologists, chemists, physicists, even anthropologists all working on it.
I got to admit, this whole natural gas angle,
Yeah.
it's really making me rethink this whole Tunguska thing. It's like adding this whole other layer to the mystery.
Yeah, it is. It reminds us that sometimes the most unexpected answers, they're right there in front of us. And it shows how powerful it can be when you combine science with, cultural stories and observations.
So we've got this potential explanation for the sheer power of Tunguska. But I got to ask, is there anything else hidden in the Evenki stories that might be relevant? You mentioned earlier there might be more than one clue.
That's right. That's right. There's this other detail, almost like a throwaway line in some versions of the story. And it's really intriguing to me. They mention this scar on the land, this place where the trees just refuse to grow back after Agdi's wrath. What if this scar, this blighted area, what if it's not just mythology, but a real place?
Wait, are you saying there's a specific location, a place that could be investigated?
It's a long shot for sure. But there are researchers looking into it. They're going through old records, comparing Evenki accounts, even using satellite images, all trying to find the scar on the land.
Okay, now you've really got me curious. What could this scar tell us? What exactly are we looking for here?
Well, imagine if this scar is this zone of, like, really intense damage, something beyond just the fallen trees. What if it's a place where the ground was just scorched, maybe by this massive heat release or some kind of energy discharge?
So we're talking about more than just a meteorite impact then?
Exactly. If this scar exists and if it shows signs of unusual energy patterns, it could be evidence for some of the more, well, exotic theories that have been proposed over the years.
Like what? Don't leave me hanging.
Like the idea that Tunguska wasn't caused by a meteorite or a comet at all, but by something even more extraordinary, something we might not even fully understand even today.
Okay, now you've got me on the edge of my seat.
Yeah.
What could be more extraordinary than a meteorite impact? What else could possibly explain an explosion that big?
Well, to find that out, we're going to have to go into the realm of the truly unexpected. We'll have to look at those theories that really push the boundaries of what we know. Theories that until recently were just speculation, but now, thanks to new research and a fresh look at the evidence, they're starting to gain some real credibility.
I can't wait to hear this. Sounds like we're heading into some uncharted territory. Listeners, you don't want to miss the final part of our Tunguska deep dive. Okay, so last time we ended on a bit of a cliffhanger. You mentioned a clue in those Evenki stories, something connecting the Tunguska event to the Earth itself. I got to know. Where is this going?
All right, well, let's go back to those stories for a sec. The Evenki people, they talk about this deity, sometimes called Agdi, and he unleashed his wrath on the land, right? Now, what if that wrath, it wasn't just like metaphorical anger, but a real release of energy from the Earth itself?
Okay, I'm intrigued, but I'm a little lost. Are you saying the Earth
Yeah.
played a part in the Tunguska event?
That's exactly what I'm suggesting. And the key to this whole theory is something you might not expect: natural gas. Turns out Siberia has these huge reserves of natural gas, all trapped underground.
Natural gas, huh? Okay, I think I see where you're going with this, but how does natural gas explain an explosion that big?
Okay, so imagine this. You got a meteorite, doesn't matter what it's made of, it slams into the Earth's crust with incredible force, right? This impact creates fissures, cracks in the surface. And what if those fissures just happen to intersect with a large pocket of natural gas?
So the meteorite is like a trigger.
Yeah.
Releasing all this natural gas into the atmosphere.
That's precisely. And here's where it gets interesting. Natural gas, specifically methane, it's highly flammable, right? When you mix it with air in the right proportions, you can get a ridiculously powerful explosion.
Hold on. Could a natural gas explosion really be that strong?
Right.
Like rivaling the force of 1,000 atomic bombs? That seems, I don't know, kind of impossible.
It's a bold claim for sure, but some scientists think that combination, the meteorite impact plus that sudden release of all that natural gas, they think it could, in theory, generate an explosion that big. It's all about this synergistic effect, one powerful event triggering and amplifying another.
Okay, I'm following you. So we've got this hypothetical scenario. Meteorite hits, gas is released, boom, massive explosion. But wouldn't there be some evidence of the gas? Wouldn't people have, like, smelled it? Wouldn't there be some kind of, I don't know, lingering gas cloud?
Those are all good questions.
Huh?
And the answer, at least part of it, might lie in the limitations of scientific observation back then. Remember, this was 1908. Our ability to like detect and analyze atmospheric gases, it was nowhere near as advanced as it is today. So it's possible that the gas, even though it was a lot, it dispersed quickly, didn't leave much of a trace.
Hmm. Okay, and what about the oven people?
Hmm.
Wouldn't they have noticed the smell of natural gas?
It's possible, but here's the thing, natural gas, in its pure form, it doesn't actually have a smell. That gas smell we all know, that's an additive put in by, utility companies for safety reasons. So unless the gas had other compounds in it, stuff that would make a smell, the Evenki might not have smelled anything unusual.
Right, right. Okay. So it is possible that this massive gas release could have happened without leaving any obvious evidence behind. But is there any scientific evidence?
Yeah.
Anything to actually support this natural gas theory?
Well, it's a pretty new idea, but there are some intriguing hints. For example, some researchers have found elevated methane levels in tree rings dating back to 1908. And others have looked at the geology of the Tunguska region, looking for signs of underground gas pockets and potential pathways for those gases to reach the surface.
So we're talking about a geological detective work here, piecing together these clues, seeing if they tell a story.
Exactly. It's a fascinating puzzle, really interdisciplinary. You've got geologists, chemists, physicists, even anthropologists all working on it.
I gotta say, this whole natural gas angle,
Yeah.
it's really making me rethink the Tunguska event. It's like adding this whole other dimension to the mystery.
It is. It reminds us that sometimes the most unexpected solutions are hiding right there in plain sight. And it really speaks to the power of combining scientific knowledge with cultural stories and observations.
So we've got this potential explanation for the incredible energy release at Tunguska, but
Yeah.
but I have to ask, is there anything else hidden in those Evenki stories that might be relevant here?
Yeah.
You mentioned earlier that there might be more than one clue.
That's right. There's this other detail, almost like a throwaway line in some versions of the story that I find really intriguing. They mention the scar on the land, this place where trees they wouldn't grow back after Agdi's wrath. What if this scar, this blighted area, what if it's not just a mythological element, but a real feature of the landscape?
Wait, are you saying there's a specific location, like a place that could actually be investigated scientifically?
It's a long shot for sure, but some researchers think so. They're combing through historical records, comparing Evenki accounts, even using satellite imagery, all trying to pinpoint this scar on the land.
Okay, now you've really got me curious. What could this scar tell us? What are we even looking for here?
Well, imagine if this scar is the zone of like really intense localized damage, something beyond just the widespread tree fall that we know about. What if it's a place where the ground was just scorched? Maybe by this intense release of heat or some unusual energy discharge.
So we're talking about something more than just a meteorite impact then.
Exactly. If this scar exists and it shows signs of unusual energy patterns, it could be evidence for some of those more exotic theories that have been proposed.
Come on, don't leave me hanging.
Like the idea that the Tunguska event wasn't caused by a meteorite or a comet at all, but by something even more extraordinary. Something that we might not even fully understand even today.
Okay, now you've got me on the edge of my seat. What could be more extraordinary than a meteorite impact? What else could possibly explain an explosion that big?
Well, to find that out, we'll have to delve into the realm of the truly unexpected. We'll have to explore those theories that push the boundaries of our scientific understanding. Theories that, until recently, were considered, mere speculation. But now, thanks to new research and a fresh look at the evidence, they're starting to gain some serious credibility.
I can't wait to hear this. Sounds like we're heading into some uncharted territory. Listeners, you won't want to miss the final part of our Tunguska deep dive. All right, so deep divers, we're back for the final part of our Tunguska exploration. Last time things got pretty wild, talking about that mysterious scar and those theories that go beyond even meteorites and comets. I'm I'm ready to hear what other possibilities are out there.
Well, let's dive right into those more out there theories, shall we? The Tunguska event, it's been like a magnet for speculation for decades, attracting all sorts of ideas from the intriguing to the downright bizarre.
Oh, I bet. I remember reading something about Nikola Tesla.
Hmm.
The brilliant inventor. Some people thought he was somehow involved.
Oh yeah, the Tesla connection. That's a popular one. The idea is that Tesla, with his experiments on wireless power transmission, might have accidentally or maybe even intentionally caused the Tunguska event. Some even say he was testing some kind of like powerful energy weapon.
A Tesla death ray blasting Siberia. That's straight out of a comic book.
Right. It's a fun idea, but there's just no evidence to support it. Tesla's experiments, as groundbreaking as they weren't on the scale needed to cause something like Tunguska.
Okay, so Tesla's off the hook for now, at least. What other unusual theories have caught your attention?
Well, there's one that's both intriguing and a little unsettling. The idea that the Tunguska event was caused by a small piece of this strange, dense object, sometimes called a strangelet.
A strangelet? What in the world is that?
It's a theoretical type of matter, thought to be made up of something called strange quarks. Now, quarks, those are those fundamental particles that make up protons and neutrons, the building blocks of atoms. But strange quarks, they're strange. They're much heavier than other quarks, and they have some unusual properties.
Okay, I think I'm following, kind of. So how do these strangelets tie into Tunguska?
The theory is this. A tiny fragment of strangelet matter, maybe the size of a grain of sand, enters the Earth's atmosphere and passes right through the planet, exiting somewhere in the Atlantic Ocean. And as it traveled through the Earth, its intense density and gravity, they created this shock wave that we saw as the Tunguska explosion.
So instead of a normal impact, we're talking about an object passing through the Earth and leaving this trail of destruction in its wake. That's a pretty wild concept.
It is. And as far-fetched as it sounds, there's actually some scientific basis for it. Strangelets are a real area of research in particle physics, though no one's ever actually definitively seen one.
So we're talking about a hypothetical object based on a hypothetical type of matter. That's a lot of hypotheticals for one theory.
True. But that's how scientific exploration works sometimes. You gotta go into the unknown to find answers.
Fair enough. But let's get back to those Evenki stories for a minute. You mentioned that scar on the land, the place where the trees wouldn't grow. What if that scar is real? Could it provide any evidence for these more unusual theories?
That's the $1 million question. If the scar exists and it has like unusual characteristics like radiation anomalies or strange electromagnetic readings, it could support those theories about, exotic matter or unusual energy releases.
So finding this scar could be the key to finally solving the Tunguska mystery.
It's definitely a possibility, and that's what makes Tunguska so fascinating even after all these years. It's a mystery that keeps challenging us, challenging our understanding of the universe and our place in it.
Yeah, and it reminds us that there's still so much we don't know, so much out there left to discover. Well, I gotta say, this deep dive, it's been quite a journey. We've covered everything from meteorites to antimatter to strangelets and Tesla death rays. So where does all this leave us? What's the takeaway for our listeners?
I think the biggest takeaway is that the Tunguska event, it's this powerful reminder of the mysteries that are still out there. It's a story that blends science and history, even mythology. It reminds us that the search for knowledge, it's an ongoing adventure.
Well said. And who knows, maybe one day, with more research and a little bit of luck, we'll finally solve the Tunguska puzzle. But until then, let's embrace the mystery and keep those minds curious.